Hello everyone, I am Asirvad Mohanty. Today we will discuss about motion in plane polar coordinates. Okay, so as you know that in many applied problems it is more convenient to use other coordinates instead of Cartesian coordinate systems. For example, we can use plane polar coordinates if we are considering motion in a plane. We can use spherical polar coordinates and cylindrical coordinate systems if you are considering motion in 3 dimension. Okay, so we'll start from plane polar coordinates. Okay, so let's say we are confined to xy plane. That means here is x axis, here is y axis. Let's say any point is P. Its coordinate in Cartesian coordinate system means xy. Okay, let's say the point P is at a distance r from the origin, and let's say theta is the angle it makes with x-axis. Okay, so here the coordinates r and theta are called plane polar coordinates. Okay, plane polar coordinates. Okay, so let's say this distance is x, and you know that this distance is y. So here it is a right angle triangle, so we can write cos theta equals to x divided by r. So x equals to r cos theta. Similarly, we can write sin theta equals to y by r. That means y equals to r sin theta. Okay, so these are the relations between the Cartesian coordinates, that is x and y, and the polar coordinates, that is r and theta. What is r? R is the distance of the point P from the origin, and what is theta? Theta is the angle it makes with x-axis. Okay, so the relation between Cartesian coordinates in terms of polar coordinates is x equal to r cos theta and y equals to r sin theta. Similarly, we can express the polar coordinates in terms of Cartesian coordinates, like we can write r equal to square root of x square plus y square, and also theta equal to tan inverse y by x. Okay, here x square plus y square equal to r square, so r equal to square root of x square plus y square, and here y by x equal to tan theta, so theta equal to tan inverse y by x. So this is the polar coordinates r and theta in terms of Cartesian coordinates x and y. Okay, so these are the relations between Cartesian coordinates x and y and polar coordinates r and theta. Okay, so what is the difference between the coordinates in Cartesian coordinate system and coordinates in plane polar coordinate system? We will discuss that. Okay, so let us draw the constant coordinate lines. Okay, let's say the constant coordinate lines. We will draw the constant coordinate lines. Okay. Constant coordinate lines means the lines on which the particular coordinate remains constant. Okay, so we'll first do it for Cartesian coordinate system. Okay, so for Cartesian coordinate system, we will draw constant coordinate lines. Let's say this is x-axis and this is y-axis. So constant coordinate lines means lines parallel to x-axis. On lines parallel to x-axis, y is constant but x varies. Similarly, lines parallel to y-axis, on those lines x is constant but y varies. So the lines parallel to x-axis, that means y equal to constant but x varies. Okay, for this line, Similarly, for this line, that means line parallel to y-axis, on this line x equal to constant but y varies. Okay, so it is clear. So we know that lines parallel to x-axis, on that lines y equals to constant, but x varies. Lines parallel to y-axis, x constant and y varies. But the constant coordinate lines are perpendicular to each other and straight lines. Okay, all the lines are straight lines and perpendicular to each other whenever they intersect with each other. This is for Cartesian coordinate system. Okay, now we'll draw constant coordinate lines for polar coordinate system. Okay, so for plane polar coordinate system, we'll draw constant coordinate lines. Let's similarly say here is x-axis and this is our y-axis. So lines of constant theta, let's say here is theta is 30 degree, here theta is 60 degree. Similarly here, these are the lines of constant theta. So for constant lines for constant theta, the lines are straight lines. That means the theta equal to constant lines are straight. Similarly, for lines r equals to constant are circles. Okay. So the coordinate lines for theta constant are straight lines and radially outward. On these lines, theta equals to constant, but r varies. Okay. But on these circles, here r equals to constant, but theta varies. Okay. So these are the things. So for theta equal to constant, these are straight lines. But for r equal to constant, these are circles concentric to origin. Okay, so this is the difference. That means in Cartesian coordinate system, all the constant coordinate lines are straight lines, but here for r equal to constant, these are concentric circles. But the case is same, that here x and y coordinates and y coordinates are perpendicular to each other. Here also the same thing. R and theta are perpendicular to each other whenever they intersect. Okay, so this is clear. Next thing is we'll calculate the area element. Okay, area element in polar coordinate system. As you know that area element in Cartesian coordinate system, how to calculate that? We know the area element. Let's say here is the distance dx, here is distance dy. So how much is the area element? Area element is the area of this small grid. So here the area element, let's say dA is how much? Length times length. So dx times dy. So this is the area element in Cartesian coordinate system, that is dx times dy. Okay, here is a small grid. So the area element is dx times dy. Similarly here, in plane polar coordinate system, we can calculate the area element. How to calculate that? Okay, let's say here is the angle theta, here is the angle d theta. Okay, so this angle is theta and this small angle is d theta. Okay, if this is d theta, let's say the distance here is r. Okay, okay, let's say here the angle is theta. Let's say this is the grid. Okay, so we have to calculate area of this region. This is the area element. This region, any region is the area element. Okay, we have to calculate area of this small region. How to calculate that? Let's say this distance is dr. Okay, this distance is dr. That means here r changes. Let's say this distance is dr, and this distance is if this is this is r and this angle is d theta, so this length is r d theta. Clear? Okay, this side has length dr and the small angle is d theta, so this arc length is r d theta. If this is r d theta, then the area element will be how much? Then the area element dA is r d theta times dr. So this is r d theta times dr. So here dA equals to r dr d theta. So this is the area element in polar coordinate system is r dr d theta, and the area element in Cartesian coordinate system is dx times dy. Okay. So so we'll calculate the arc length. Okay, arc length element in plane polar coordinate system. Okay, so we'll do that. Okay, so this is clear. So next time the arc length element in polar coordinate system. Okay, so how to calculate that? Let's say this is our x-axis and this is our y-axis. Let's say here is an arc. Let's say this distance is r, and this distance is here if we draw a perpendicular on this line, so this distance is also r. So this is the change in length is dr. Okay, and let's say this angle is theta and this small angle is d theta. If this is d theta, then this side is r times d theta. From this form, this is dr and this is d theta. So this arc length, let's say this is ds, then you can write ds square is dr square plus r d theta square. This is ds square is dr square plus r d theta square. So ds is r square plus r square d theta square. This is ds square. So ds can be written as square root of r square plus r square d theta square, or we can write it ds equals to r times 1 plus this is clear. ds equals to r square plus r square plus d theta square. So this is the arc element, arc length element in polar coordinate system. Okay, so this is the thing, and our next task is to calculate the unit vectors in Cartesian coordinate, unit vectors in polar coordinate system. As we know that unit vectors in Cartesian coordinate system are I cap and j cap. I cap points in the direction of increasing x, and j cap points in the direction of increasing y. Let's say if this is x axis, this is y axis. Here I cap points in the direction of increasing x. Similarly, j cap points in the direction of increasing y. Similarly, let's say here is a point P, its coordinate is r theta, then we can use our Cartesian, the unit vectors in polar coordinates, those are r cap and theta cap. R cap and theta cap are unit vectors in polar coordinate system. In polar coordinate system. Okay, so r cap and theta cap are the unit vectors in polar coordinate system. So r cap will point in the direction of increasing r, and theta cap will point in the direction of increasing theta. Let's say this is the point, here is the point. So the direction of r cap is along the direction of increasing r. Similarly, if this angle is theta, then theta cap will point in the direction of increasing theta. So the direction of theta cap is in this direction. Okay, clear? So r cap points in the direction of increasing r, and theta cap points in the direction of increasing theta. Okay, and this r cap and theta cap are perpendicular to each other. Okay, we'll show that. Okay, so this is the unit vectors in plane polar coordinate system. But there is a difference between the unit vectors in Cartesian coordinate system and unit vectors in polar coordinate system. Okay, we'll discuss that. The thing is that the unit vectors, that is I cap and j cap, are constant. That means the directions of I cap and j cap are fixed, that do not change with position. But r cap and theta cap, the directions of r cap and theta cap changes with position. Okay, we'll show that. Okay, so let's say here we'll consider 2 points. Okay, so let's say first point is P and second point is Q. At point P, let's say here is the distance is r1 and the angle is theta 1. So r1 cap will point in this direction and theta 1 cap will point in this direction. But here, as this is x-axis, this is y-axis, I cap is along x-axis and j cap is along y-axis. Okay, so this is the situation at point P. Next, the situation at point Q. Let's say this distance at the point Q. Let's say this distance is r2 and the angle is theta 2. So this is the direction of r2 cap and this is the direction of theta 2 cap. And here the direction of I cap is parallel to x-axis and j cap is parallel to y-axis. So we see that the directions of I cap and j cap, here I cap is along x-axis and j cap is along y-axis. Those directions are fixed. That means they do not change with position. Going from theta 1 to theta 2, they do not change. But here r1 cap has a different direction than r2 cap. Okay, r1 cap is in this direction, but r2 cap is in another direction. Similarly for theta 1 cap and theta 2 cap. Okay, so understand? So this is the difference between unit vectors in Cartesian coordinates and plane polar coordinates. The unit vector I cap and j cap are fixed in position, but the directions r cap and theta cap changes with position. Okay, we know that r cap and theta cap changes with position, but r cap and theta cap changes only with theta. That means when theta changes, let's say here theta is 30 degree, here theta is 60 degree. When theta changes, then r cap and theta cap both changes. Okay, that means r cap and theta cap are functions of theta, not on that means they do not depend on r. Okay, if r changes, let's say here is r. If r changes, let's say here, that means r is the magnitude of the distance. So if r changes, then the direction of r cap and theta cap will remain same. That means r cap and theta cap depends only on the theta. If theta changes, then r cap and theta cap will change. That means r cap and theta cap are functions of theta. Okay, so now we'll see the expression for r cap and theta cap in terms of theta. Okay, and the relation between Cartesian unit vectors I cap, j cap and r cap and theta cap. Okay, so we'll do that. So here is the thing. Let's say here is the point P. Okay, and here is the point. Let's say here is the direction of r cap and the direction of theta cap. This distance is r and this angle is theta. This is x-axis, this is y-axis. I cap points in the direction of x-axis and j cap points in the direction of y-axis. Okay, they intersect at this point P. Okay. So here the direction of I cap is in this and j cap is in this direction. As you know that r cap, theta cap, I cap and j cap are unit vectors. That means their magnitude is equal to 1. So the magnitude of r cap, theta cap equals to 1. Similarly for the magnitude of I cap and j cap equals to 1. So this is unit magnitude, r cap also unit magnitude, I cap also unit magnitude, theta cap also unit magnitude. That means if this angle is theta, then here also this angle is theta. If this angle is theta, if we draw perpendicular from r cap on I cap axis, then this distance is how much? Then this distance, as r cap has unit magnitude, this distance is cos theta. Similarly, this distance is sin theta. Clear? R cap is the unit vector, that means its magnitude is 1. So this distance is cos theta and this distance is sin theta. If this is cos theta and this is sin theta, so we can write r cap equals to, r cap is a vector in this direction, so we can write r cap is this vector plus this vector. So this vector is cos theta I cap and this vector is sin theta j cap. So you can write this is equals to cos theta I cap plus sin theta j cap. Clear? So r cap equal to cos theta I cap plus sin theta j cap. And next thing is to calculate theta cap. Okay, so here is theta cap. So similarly you can draw here. Okay, theta cap is in this direction. So as theta cap has magnitude 1, so this is okay here. This angle is theta. Okay, if this angle is theta, then this angle equal to theta. That means this is 90 minus theta. If this is 90 minus theta, then this part will be equal to sin theta, and the perpendicular part will be cos theta. Okay, as you know that I cap is in positive x direction, so in negative x direction this is minus I cap, because theta cap equals to this vector plus this vector. This is a negative x axis. Negative x axis means this is minus I cap sin theta, this is cos theta, j cap cos theta. Okay, this is j cap cos theta. This is in positive y axis, but this is in negative x axis, so this is minus I cap sin theta. So you can write theta cap equals to minus sin theta I cap plus cos theta j cap. So this is the expression for r cap and theta cap in terms of I cap and j cap. So it is clear that r cap and theta cap are functions of theta only. Okay, they are not function of r, they are functions of theta only. That means if theta changes, then r cap and theta cap will change. Okay, so this is the thing. Okay, our next part. Okay, so here we can verify that r cap and theta cap are perpendicular to each other. That means if we take the dot product between them, r cap dot theta cap will be equal to minus sin theta cos theta plus sin theta cos theta. So this is equal to 0. That means r cap is perpendicular to theta cap. That means the direction of r cap and theta cap are perpendicular to each other. Okay, so this is clear. So our next thing is to calculate. Okay, another thing that you know that how to do dot product. Okay, in Cartesian coordinate system, we write any vector. A vector is let's say for a vector in a plane, xy plane, we can write ax I cap plus ay j cap, and we can write b vector is bx I cap plus by j cap. And what is the expression for dot product? This is equals to ax bx plus ay by. So this is the expression for dot product in our rectangular or Cartesian coordinate system. Similarly, in plane polar coordinate system, we can write any vector a vector as a r cap plus a theta theta cap, and any vector b vector as b r cap plus b theta theta cap. So how much will be a vector dot b vector? This is equals to a r b r plus a theta b theta. Okay, so this is the expression for dot product in polar coordinate system. Okay, so this is clear. Our next task is to calculate the expression for position vector in Cartesian coordinate, polar coordinate system. Okay, so first we will do the expression for position vector in polar coordinate system, then we will do the velocity, then acceleration. Okay, so we will do step by step. Okay, we will use that. Only thing left is r cap equals to we will write it right here. R cap equals to cos theta I cap plus sin theta j cap, and theta cap equals to minus sin theta I cap plus cos theta j cap. So this is the thing. Okay, so the position vector. Okay, position vector. Okay, in polar coordinate system, we can write the position vector r vector as r cap. Okay, okay. This is in polar coordinate system. In polar coordinate system. Okay, so what is the expression for position vector in Cartesian coordinate system? The expression for position vector in Cartesian coordinate system for a two-dimensional space, this is x I cap plus y j cap. This is in Cartesian coordinate system. Okay, Cartesian coordinate system. So you can compare that these two things are same. Okay, so because you know the relation between from the relation between Cartesian coordinate and plane polar coordinate, x equal to r cos theta and y equals to r sin theta. So we can write here in place of x we can write r cos theta I cap plus r sin theta j cap. So this is equals to r times cos theta I cap plus sin theta j cap. So this cos theta I cap plus sin theta j cap is almost, this is r cap. So this is r cap. So we found that the expression for position vector is r cap. Okay. So this is the expression for position vector in polar coordinate system. Okay. So our next task is to calculate the expression for velocity in polar coordinate system. Okay. So you know how to calculate velocity in position vector. Okay. How to calculate this? We have to take time derivative of position vector. Okay. In order to calculate velocity, we have to take time derivative of position vector. So how much is the expression for velocity in Cartesian coordinate system? You know, in Cartesian coordinate system, the expression for velocity is v is the time rate of change of position vector. So this is d by dt of x I cap plus y j cap. So you can write this is dx by dt I cap plus dy by dt j cap. So you can write this dx by dt as x dot I cap plus y dot j cap. So this is the expression for velocity in Cartesian coordinate system. In a similar manner, we can calculate the expression for velocity in polar coordinate system. So in plane polar coordinate system, okay, in plane polar coordinate system, the expression for velocity is the time rate of change of position vector. So this is d by dt of, and how much is the position vector? This is r cap. So we can apply product rule here for differentiation. So this is dr by dt r cap plus r dr cap by dt. Clear? Okay. So this is dr by dt r cap, r times dr cap by dt. Similarly, we can write here dr by dt as r dot. So this is r dot r cap plus r dr cap by dt. Okay. So we have to calculate this dr cap by dt. Here is r cap, so you have to calculate dr cap by dt. Okay. So dr cap by dt is d by dt of, the expression for r cap is almost, this is cos theta I cap plus sin theta j cap, and so cos theta d by dt of cos theta means this is minus sin theta, theta dot means d theta by dt. Okay, so you can write d theta by dt as theta dot plus sin theta differentiation is cos theta, theta dot j cap. So if you take theta dot common, then this is equals to minus sin theta I cap plus cos theta j cap, and this minus sin theta I cap plus cos theta j cap, this is theta cap. Okay, so this is theta dot theta cap. So this is clear. So we found that dr cap by dt is theta dot theta cap. Okay, we will write here dr cap by dt is theta dot theta. So here we can put the value of dr cap by dt. Okay, so if we put there, so this will be equals to r dot r cap plus r, this is theta dot theta cap. Okay, so the expression for velocity is r dot r cap plus r theta dot theta cap. So the velocity has two parts, one is r dot r cap and second part is r theta dot theta cap. So this first part is called radial velocity and second part is called tangential velocity, because r cap is the radial direction, that is along the radius, and theta cap is in tangential direction. Okay, the radial direction and tangential direction are perpendicular to each other. Okay, so we'll discuss more about this. Okay, more about the radial part and the tangential part. Okay, so so let's say from case 1, if r equals to constant, okay, let's say if theta equals to constant, if theta equals to constant, then theta dot equals to 0. If theta dot equals to 0, then velocity is only r dot r cap. Okay, this is only r dot r cap. This is the radial velocity. This is the radial velocity. That means the velocity is along the radius. Theta equals to constant. That means r. This is a straight line. Okay. So here is the velocity. Let's say this is your r vector. So velocity is r dot r cap. This is the direction of velocity. That means the direction of velocity is in the direction of the position vector. If theta constant. Okay. In the second case, if r equals to constant, okay, if r equals to constant, then r dot equals to 0. That means v vector equals to r theta dot theta cap. This is the tangential velocity. This is the tangential velocity. That means the velocity is only in tangential direction. R equals to constant. That means on a circular path. Okay. On a circular path, r equals to constant. The radius remains same here, the circular path. On that path, the velocity is in, let's say here is the position vector r vector. So this is the direction of theta cap. The velocity is r theta dot theta cap. Okay, clear? So when both r and theta changes with time, then the velocity is both radial part and tangential part. This is the theta cap is in tangential direction. Why tangential direction? Because this is perpendicular to the r vector at this point. Okay, on a curve. So this is the tangential direction. Okay, so this is about the velocity in polar coordinate system. So next we'll calculate the expression for acceleration in polar coordinate system. Okay, so the velocity is this. Okay, so we'll do the acceleration in polar coordinate system. Okay, as you know that similarly in Cartesian coordinate system, we can calculate acceleration as a rate of change of velocity. Okay, similarly here we'll do the time derivative of the velocity vector. So this is equals to d by dt of r dot r cap plus r theta dot theta cap. Okay, so we'll differentiate both the terms. Okay, so this is equals to d by dt of r dot r cap plus d by dt of r theta dot theta cap. So this is equals to, okay, we will do here. So this is equals to d by dt of r dot r cap plus r dot dr cap by dt. Okay, we'll write like this. Okay, here is r cap plus here this is dr by dt theta dot theta cap r d theta dot by dt theta cap plus r theta dot d theta cap by dt. Product rule. We are using product rule. Okay. So here we can write this dr dot by dt as r double dot. Okay, r double dot r cap. Here dr cap by dt, we know the expression for dr cap by dt is theta dot theta cap. So this is theta dot theta cap plus dr by dt. We will write this r theta dot theta cap. D theta cap by dt. Okay, so we have to calculate this d theta cap by dt. So first we will calculate this. Okay. Sorry. This is d theta dot by dt. Sorry. This is d theta dot by dt. So we can write this as r theta double dot theta cap. So this is d theta cap by dt. So we have to calculate d theta cap by dt. So we'll do here d theta cap by dt is how much? This is minus cos theta theta dot I cap, and this is minus sin theta theta dot j cap. So if you take the minus sign outside, okay, so this is equals to minus sorry, this is j minus sin theta j cap plus cos theta I cap, okay, minus theta dot. So this is equals to minus theta dot, this cos theta I cap plus sin theta j cap is r cap, so this is minus theta dot r cap. So we found that d theta cap by dt equals to minus theta dot r cap. Okay, so clear? So this is d theta cap by dt, so this is equal to minus theta dot r cap. So in place of d theta cap by dt, we'll write minus theta dot, so this will be equals to minus r theta dot square r cap. Okay, so here is the r cap term, here is r cap term, we'll bring them closer. So this is r double dot minus r theta dot square r cap, plus this is r theta dot theta cap, r theta dot theta cap. So we will write that r theta double dot plus 2 r dot theta cap. Okay, so this is the expression for acceleration. Okay, so the acceleration has also two parts, one is radial acceleration and second one is the tangential acceleration. Okay, same thing. Okay, so we'll define each and every term, that and all the four terms. Let's say we'll start from the first term. The first term r double dot r cap is the linear acceleration in radial direction. Okay, this is in radial direction, and this happens due to change in magnitude of radial velocity. Okay, we know that velocity changes, acceleration happens when velocity changes, and the velocity has two parts, one is magnitude of velocity and second one is direction of velocity. So when magnitude of velocity changes, then acceleration happens. Here is the thing, this r double dot r cap is the linear acceleration in radial direction. This happens due to change in magnitude of radial velocity. Okay, and here is the term r theta double dot. Okay, so this r theta double dot theta cap, this is also linear acceleration. Okay, so this is also linear acceleration in tangential direction. But this happens due to change in the angular velocity. Okay, this happens due to change in angular velocity. If the angular velocity changes, then this acceleration happens, the linear acceleration in tangential direction. And this part minus r theta dot square r cap, this is centripetal acceleration. This is centripetal acceleration. We know this acceleration in circular motion. The centripetal acceleration is minus r cap. That means this acceleration always acts towards the center. Okay, the r cap is the radially outward direction. This is minus r cap. That means radially inward. So the centripetal acceleration is towards the center. Okay, and the last part 2 r dot theta cap is the Coriolis acceleration. Okay, this is the Coriolis acceleration. This Coriolis acceleration happens when both r and theta changes with time. That means in the term r dot and theta dot are present. So when both r and theta changes with time, then Coriolis acceleration happens. So these are the four terms in the expression for acceleration. Okay, so this is the thing. So we have discussed the motion in plane polar coordinates. First we have discussed about the relation between Cartesian coordinates x and y and polar coordinates r and theta. Then we discussed the expression for unit vectors in polar coordinates and the relation between the unit vectors r cap, theta cap, and I cap and j cap. And then we derived the expression for position vector, then velocity and acceleration. Okay, so we'll stop here. In the next class, we'll discuss about the expression for velocity and acceleration in spherical polar coordinates and cylindrical coordinates. So thank you all.